Hello children, welcome to Zero Panic Maths. Okay, now in today's session, let us continue our discussion on the representation of a rational number on the number line. Okay, now in the previous session, we have seen how exactly the rational numbers are defined and how do we identify the rational numbers between the two whole numbers, or you can say between the two consecutive numbers. How does the rational numbers may arise? Okay, and the definition of that also, that a rational number is represented in the form of p by q, where q is not equal to 0 and p and q are integers. Okay, now in today's session, let us continue to represent this rational number on a number line. Now till now, in the previous two sessions, if you have not watched that videos, you can watch those videos. Link is given in the description, because you know how to represent the integers, the positive integers and the negative integers on the number line. Okay, but how do we represent the numbers that exist between these two consecutive numbers? Those are actually the fractions, or we also call them as rational numbers. Okay, now you can see this is a origin. Okay, and 1 2 3 4, because one unit is equal to one number, as we generally consider a number on the number line. Okay, now how do we represent a rational number on the number line is the concept to be discussed here. Okay, now you can see, just consider this number between 0 and 1. Okay, between 0 and 1 there is one unit. Okay, so it's very simple. Just listen to me carefully. And there is one fraction that is represented in between 0 and 1, that is 1 by 2, which is half. 1 by 2, which is half, which is less than 1. Correct? So if you consider, you see that the given unit is divided into two parts, and one part of the available two parts is represented. What do you mean by 1 by 2? 1 by 2 is the first part of two units, first part of two parts, you can say that. Okay, so that is half of 0 to 1 unit, that is 1 by 2. And here there is one more representation of that minus 3 by 4, which is there between 0 and minus 1. Just listen to me carefully, that you have a 0 here, okay, and 1 here. Okay, and how are you representing 1 by 2 here? Okay, just listen to me carefully. What you are doing is, given unit 1, you are dividing it to two parts and moving one part from 0, right? Moving one part from 0. You see that 1 and 2, two parts you divided and went to one part of the available two parts. Here, when you are considering 3 by 4, you have to divide the given unit from 0 to minus 1 into four parts. Okay, remember this. So how are you representing 0 to minus 1? You are first dividing that into four parts. Okay, assume 1 2 3 4 parts. Okay, and this is the first part of the four parts, this is the second part of the four parts, and this is the third part of the four part. Okay, so it is minus minus minus. This is what minus 3 by 4, how you are representing here. You understood this? Okay, so whenever a fraction is to be represented in between the two given integers or one unit, you divide that unit. That is, unit is nothing but the distance between the two consecutive numbers. Okay, divide that unit into q equal parts. What is 4? 4 here is denominator, and denominator is p by q. In the form of p by q, it is q. So divide that into q parts and move p parts apart from 0. Okay, so and while moving from 0 to p parts, you have to move to the left if the number is negative. That example is minus 3 by 4. And you have to move to the right p parts if the number is positive. So in general, they are saying, see that note, it's very important. In general, when a rational number p by q is to be represented on the number line, then divide the unit interval. Unit interval is the interval between 1 and 2, 0 and 1, 0 and minus 1, minus 1 to minus 2, 1 unit. Okay, 2, 3, like that. That unit interval should be divided, and that unit interval is actually the distance between the two consecutive integers, into q equal parts. Then move P parts from 0 to the right. From 0 to the right, Q part you should be moving if the number is positive. If the number is positive, because from 0 to right side they are positive numbers. Okay, and to the left if it is negative, because you know that from 0 to the left they are negative numbers and to the right they are positive numbers. You understood, right? Let us represent this and see some examples to identify that. Listen to me, this example very important here. Okay, so what they are saying here is even fractions greater than 1 can be located on the number line in this way. Okay, how to represent a fraction which is greater than 1? There is an example of 9/4. Okay, so whenever just one simple explanation, if you are saying 2/3, okay, or 1/4, see, the numerator is less than the denominator, then it means that the number is less than 1. Correct? If the numerator is greater than the denominator, then this number is greater than 1. You have to understand this first. Okay, so here the example is 9/4. 9/4 can be represented as, see, 4 2s are 8 and 1 remains. You can write it as 2 and 1/4. 9/4 can be written as 2 and 1/4. You know this trick, right? So if you convert this back, 4 into 2 8 plus 1 9/4 it is. You have to write this way. Okay, so I'm taking an example of 9/4 which is greater than 1, and how do I represent that on the number line? You see this example, 9/4 which is 2 and 1/4. So it lies between, see, it is already 2 and 1/4. Okay, see it carefully. If it is 2 and some value, then it is definitely going to appear between 2 and 3. Correct? So that is what they are saying. It lies between 2 and 3. So the unit that you have to divide is between 2 and 3. You just see this portion of the number line. This is 2 and this is 3. And what is the rule when you want some number to be represented on the number line? Then it is now Q. What is Q? Q is 4. Q is 4. So I am going to divide the unit between 2 and 3 into 4 equal parts. Suppose this is 2. Okay, this is 2 and 3. Just see this. Okay, just see this, very important. I am dividing this into 4 equal parts. Okay, so 4 equal parts means this is the first part of 4 equal parts. This is the second part of 4 equal parts, and this is the third, and this is the fourth point. Okay, so totally 1 2 3 4 points. You understood, right? Okay, now see why it is written as 9/4 here, because 2 and 1/4 it is. Okay, this 1/4 is after 2. You are getting my point? So it is 2 and 1/4. 2 and 1/4. It is 4 into 2 and plus 1 9/4. So the first point, it is 9/4. Secondly, here it is 2 and 2/4. 2 and 2/4. This is the 2 and 2/4. What is that? 4 into 2 8. 8 plus 2 10. 10/4. Okay, what is 10/4? What is 10/4? It is 2 5s and 2 2s. So that is what it is represented here, 5/2. You're getting my point? Okay, now next, what is this? It is 2 and 3/4. 2 and 3/4. 4 into 2 8. 8 plus 3 11. 11/4. You understood this? Okay, but our point is to represent 9/4. Understood, right? Okay, now let us take one more example. If suppose you want to represent 3/4 plus 3/4. You see this part? It's very simple. Again, see, between 0 and 1 you want to represent 3/4. Now as I already told, what is 3/4? 3/4 is a number which is less than 1. So obviously the number will lie between 0 and 1. According to the rule, you have to divide the unit between 0 and 1 into 4 equal parts. And what are those 4 equal parts? Is 1/4, and this is actually 2/4. 1/2 is 2/4, right? It is 1/4. It is 2/4, and this is 3/4. This is 3/4. So this is how you represented 3/4 on the number line. So there are some numbers that are given between 1 and 2 also, which is greater than 1 but less than 2. See, for example, here 5 by 4 greater than 1, 3 by 2 greater than 1, 7 by 4 greater than 1, but all those numbers are less than 2. That is the reason they lie between 1 and 2. Okay, hope you got this. Okay, now you can just verify that how these numbers 5 by 4, 3 by 2 and 7 by 4 appear between 1 and 2 like this by this way of calculation. Okay, hope you got this. So this is how you are representing a rational number on the number line. Okay, okay, now let us see what is an absolute value of a rational number. So you might have heard this term absolute value. Okay, absolute value is usually represented like this. If suppose if you are finding out the absolute value of some number, then that number is always represented in the modulus symbol. Okay, now you assume this is a modulus symbol. It always represents the distance from 0 on the number line. Okay, so obviously, see, when you say modulus, you suppose modulus of 5 or absolute of 5 is also 5, and minus 5 if you take, this is also 5. You might be knowing this. Okay, so absolute is nothing but the positive value of the unit or the quantity that is given inside that two vertical lines. Okay, this symbol, this is absolute. And on the number line, how do we represent that absolute? Because see, if you are saying absolute of 2, absolute of 2, you see that absolute, listen to me carefully, absolute of 2 is 2 and absolute of minus 2 is also 2. It always represents a positive value of the quantity involved in it, so it just negates whatever is there with the negative values there. Okay, so now why I am saying this 2 and 2, because you see this line very carefully. You see this line, that distance from 0 on the number line, it just represents the distance from 0 to that number. Suppose, see, it is 2. What is the distance here? It is 2. And minus 2 also, I'm saying from 0 to this, what is this distance? It is 2. So it always represents a distance from that number to that number from 0. Either it is on the positive side or negative side, the distance always represents a positive number. That's why we call the absolute of any number is a positive number. Okay, now, even if there are some arithmetic operations happening within that absolute symbol, that also is given as a positive value, and that example is there here. You see that? So as I already told, this x in general, absolute of x is greater than or equal to 0. But if there are two rational numbers a and b, and if you want to find out the distance between them on the number line, between a and b can be both positive and both negative, or one positive and one negative also. Okay, so assume that there are two rational numbers a and b, and you are trying to find out the distance between them on the number line, and that is always given by, the distance is always given by absolute of a minus b, absolute of a minus b. Okay, now listen to me carefully. The example here given is distance. You are trying to find out the distance between the two integers or fractions. You can say minus 4 and 3. Okay, minus 4 is on 4 units left of the 0, and 3 units, 3 is 3 units right from the 0. So this part, okay, now let me write this. If you see, if you represent, first of all, if you represent 3, what is this 3? It is 3. Correct? 3 units from 0 to the right, because it is plus. And what is minus 4? Minus 4 is actually 4 units to the left. So this is 4. 4 plus 3, which is 7. You understood, right? So it is, the distance is 7 units, and a minus b, the absolute of a minus b is 7. Or mathematically also, you see that what is a? They are saying minus 4. A is minus 4, and what is b? it is 3, and they are saying how do you find out the distance is a minus b. So I've taken minus 4 minus 3, and what is minus 4 minus 3 is equal to minus 7. Okay, and according to this rule, absolute of x, whatever may be the x, that is always gives you the positive value. So that is 7. Absolute of minus 7 is also 7, and absolute of plus 7 is also 7. So this is how we mathematically got the distance between the two numbers on the number line. Or even if by the definition of this the actual rational number, that is the distance from 0 to that given number, also you can find out that the distance is 7 units. You understood, right? Okay, now let us move to the density. There is one more important concept that you need to know about the rational numbers, that is density. Okay, so what is density? You see that listen to me carefully. When you have the number between 1 and 2, okay, there are some fractions that are there between 1 and 2. Okay, now suppose first you divided one the unit between 1 and 2 into two parts. Okay, and you got 3 by 2 as one value. What is 3 by 2? 3 by 2 is 1.5. Correct. So that is half part after 1 and half part before 2. So this is 3 by 2. Now, then see, you divided the unit between 1 and 2 into two parts. Now you take this point and divide this point into two parts. Again, you can take 5 by 4 and divide this and take this part. Again, when you take this point, you can divide that and one more point. So this way, whatever may be the distance between the two fractions on the number line, you can always take half of that and divide that number line into two parts. Again, the one point, you keep one point fixed and take the point in the middle and divide that distance also into half. So that means there are infinitely many numbers that may arise or that may exist between two given fractions or two given unit numbers on the number line. That is what is called as dense. Dense means compact. There are very compact values that might exist between the two units. Okay, so that is what is called as density of a rational number. So you can see this is an example of that. Between any two integers, say 1 and 2, there is a rational number 3 by 2. First of all, you found 3 by 2. How did you find out 3 by 2? Is you have taken the average between the two numbers. So between 1 and 2, it is 1 plus 2 divided by 2. How are you taking the average? Average is adding the two numbers and dividing it by 2. Okay, so taking the average of 1 and 2, you found out that there is one value 3 by 2 between 1 and 2. And now you have taken 1 plus 3 by 2. 1 plus 3 by 2, that is 5 by 4. Correct. If you add 1 and 3 by 2, you will get 5 by 4. That is the midpoint between 1 and 3 by 2. That is the average of 1 and 3 by 2. So that way, furthermore, you can add 1 and 5 by 4 and find out one more value that might exist between these two. So that way, they are saying between 1 and 3 by 2, there is another rational number 5 by 4. So note that no matter how close the two rational numbers are on the number line, you can always find another rational numbers between them by taking their average. By taking their average. Average means the midpoint of the two given numbers. That is what that I explained it here. You understood, right? And that concept of having infinitely many numbers between the two units is called as density. That's why we call that the rational numbers are dense. Now let us see the exercise sets based on the concept that what we have studied. Representing a number on the number line, and there are some other concepts that we studied, right? So let us see the exercise set 3.4 and see the first problem. Okay, now what does the first problem says is represent this rational numbers 2 by 3, minus 5 by 4 and 1 by 2. So I have 1 and half, okay, on the single number line. Okay, now I've taken a number line here. Let me write this as 0, 1, 2, okay, and to the left it is -1 and -2. Now you have to first see to represent 2 by 3, -5 by 4 and 1.5 on the same number line. You have to first see where does these numbers may be existing. Okay, so you see that first 2 by 3, since it is less than 1, the number is less than 1. How do you identify whether the number is less than 1 or not? That numerator should be less than denominator. So it is obviously positive and less than 1. So it should be existing between 0 and 1. Okay, now if it is existing between 0 and 1, then what is the next point? Next point is divide the unit between 0 and 1 into 3 equal parts, because it is 2 by 3, right? Q equal parts, it should be divided. So let me divide that. Listen to me carefully. 1 and 2 parts. See, you have to count the parts. Okay, don't count the points that I am making. Okay, it is the part that is divided this unit into. So 0 to this 1 part, 2 part and 3 part. So from 0 it is there are 3 parts I divided. It is first part, first point of the third 3 parts here. This is the second. Okay, and this is third. Why I say this as third? Because it will be 3 by 3. 3 by 3 is 1. You understood, right? Understood, right? Okay, now what is this? 2 by 3. See, this is that point, 2 by 3, that you are representing. This is this first number. This is the first number. Hope you understood this. Now -5 by 4. Now as it is given as -5 by 4, it will be existing to the left of the 0, obviously between the 0 number, sorry, between the negative numbers. Okay, now and 5 by 4 is the quantity. 5 by 4 is the quantity. So obviously you can see that, forget about the symbol. 5 is greater than 4, so it exists between -1 and -2. Understood, right? Okay, -1 and -2. So how I'm dividing that? The unit between -1 to -2 is into 4 equal parts, because the Q denominator is 4 here. So let me divide that. So 1, 2 and 3. So it is 1, 2, 3, 4 parts I divided. Now how do I represent these points that I have marked here? Is 1 of 4. Okay, it is 2 of 4, it is 3 of 4. Okay, and after -1, 1 by 4, after -1, 2 by 4 it is. Remember this. Okay, so where exactly I will get -5 by 4? What is -5 by 4? You see this is very important. -5 by 4, keep this minus symbol here only, and 4 ones are 4, 4 ones are 4, and what remained in 5? When I divide 5 by 4, 4 ones are 4 and 1 remains, that is 1 by 4. So actually -5 by 4 is -1 and 1 by 4. And where exactly I'm getting that? -1 and 1 by 4. So this point is my -5 by 4. Hope you got this. Understood, right? So how did I represent it? -5 by 4. It is -1. After that, 1 by 4 to the left, because the whole value is negative from this left. This is -5 by 4. Hope you understood this. Now similarly here, if it is positive, and also it is given clearly that this number is 1.5. 1.5 means between 1 and 2 it is going to appear. And how many parts the unit between 1 and 2 should be divided? Is 2 parts. So this is that unit. This is that unit where exactly this 1.5 is going to exist, and this is this 2 parts, and this is one of the 2 parts. It is exactly between 1 and 2. So it is 1 plus 1 by 2, that is 1.5. So this is that point, 1.5, that is required. Understood? Let us move to the next number without wasting much time on it. The problem here is to find the 3 distinct rational numbers that lie strictly between -1 by 2 and 1 by 4. Okay, so there are multiple ways of finding the different fractions that exist between the two given fractions. One of the way with what we have studied is taking the average of the two numbers. Okay, add the two numbers and divide by 2. Okay, I will tell you another number which is different from what is taking as a rational numbers average. Okay, so let me take these two numbers first. Okay, minus half and 1 by 4, minus half and 1 by 4. Now let me multiply and divide this first number by 4 and second number by 2. Okay, what I am trying to do, I will let you know. Okay, first divide and multiply the first number by 4 so that I'll get the denominator as 8. Okay, denominator as 8. Let me make this second number's denominator also as 8. So I have to multiply and divide by 2. Correct? Say 1 into 2 and 4 into 2. So here 2 into 4, that is 8, and 1 4s are, that is 4. So minus 4 by 8 is the first number and second number is 2 by 8. So I converted the denominators of the two numbers. These are actually minus half and 1 by 4 only. Okay, so minus 4 by 8 and 2 by 8. Considering the denominators are same, I can take the different numbers that exist between the integer minus 4 and 2. Okay, so I will write that. So the integers that lie between minus 4 and 2. Okay, you can take the integers only. Integers that lie between, okay, that lie between minus 4 and 2. Minus 4 and plus 2. What are minus 4 and, just imagine the number line minus 4, after that minus 3, number line like this. Okay, see, it is minus 4, after that there will be minus 3, there will be minus 2. I'm moving towards 0. Okay, minus 1, there is 0, after that it is 1 and 2. So how many numbers are there? There is minus 3, minus 2, minus 1. I can take any of these numbers and divide that by 8. That number will lie between this minus 4 by 8 and 2 by 8. So that is in turn, that is the number between minus 1 by 2 and 1 by 4 only. Okay, now you got me why I divided this number by 4 and 2 here. Okay, and made it minus 4 by 8 because I wanted that distance between minus 4 and 2. This distance I wanted, and some numbers that I can write it as minus 3 by 8 and minus 2 by 8. Any number you can take here, or 1 by 8 or minus 1 by 8. That can also be a number. Even 0 by 8. 0 is also a number that exists between minus 4 and 2, right? 0 by 8. That is 0. Understood it? Okay, so I can take these numbers only as the three fractions that exist between minus 1 by 2 and 1 by 4. You got my point, right? So this is another way that you can find out the different rationals, any number of rationals between the two given rational numbers. Okay, so let us write that. So the integers that lie between minus 4 and 2 are what are those? Minus 3, let me write that. Minus 3, minus 2, minus 1, 0 and 1. Okay, so the fractions, therefore the fractions, I can write fractions or rational numbers. Okay, so the rational numbers between 1 by 2, or you can write minus 4 by 8 and 2 by 8. It is minus 1 by 2 and 1 by 4, right? 1 by 4 are minus 3 by 8, minus 3 by 8, minus 2 by 8, okay, minus 1 by 8, minus plus 1 by 8, and so on, etc. I can write etc. So I wrote only 3 here because only 3 distinct numbers are asked. You can write any numbers over there. Okay, if you want more than 3 or 5, 6, if you want, you can make this denominator as a 16 so that you will get the numerator range as a bigger number, so that you will have any number of values in between them. Hope you understood this. Okay, so this is one way of identifying the given number of fractions between the two given fractions. Okay, Now simplify this expression. Now simplifying any arithmetic operation on the fractions should be done by the law that what we have discussed in the previous session. If you have not watched that video, you have to watch that. First thing is we have to convert the denominator into the same number, okay, and then do the operation on the numerators, the given operation, okay. So minus 1 by 4 plus 5 by 12. So just to simplify this, since it is 12, I can convert this also into 12 by multiplying it by 3 and dividing it by 3 also, okay. It is multiply and divide by 3 plus 5 by 12, okay. Now I can write this as minus 3 by 12 plus 5 by 12, okay. Now since the denominators are same, by the law of addition, okay. What is the law of addition? Law of addition is when the denominators are same, you can write the common denominator and perform or add or subtract the above numerators. It is 5 minus 3, which is 2, okay. 2 divided by 12, and that is 1 by 6. So the simplified version of minus 1 by 4 plus 5 by 12 is 1 by 6. Simple arithmetic operation only, okay. But by the law that what we have discussed in the previous session, those are called as Brahmagupta's laws, okay. You have to see that session to and identify and understand that, okay. Let us go to the next problem, okay. So the next problem says a tailor has 15 and 3 by 4 meters of fine silk, okay. If making one kurta requires 2 and 1 by 4, 2 and quarter, 2 and quarter you can say, or 2 and 1 by 4 meters of the silk, exactly how many kurtas can he make? It's a simple problem. Now this is the total amount or total quantity of the silk available, and this is the quantity required for one kurta, okay. We have to identify how many kurtas with this total he can make, okay. So now let us assume that x kurtas he can make, okay. Let us consider total kurtas is equal to x. Now if you multiply this x to 2 and 1 by 4, it gives me the total silk required to make x kurtas, right? So therefore given is, what is given? Given is 2 and 1 by 4 of x is equal to this total silk available. Total silk available is this. You understood, right? This is the total kurtas, and this is the quantity required for making one kurta. So this multiplied by x is equal to the total available silk. Total available silk. Hope you understood this. Now convert this to the proper fractions. Okay, 2 into 2, sorry, 4 into 2, it is 8 plus 1, 9 by 4. It is 9 by 4. You know this, right? How to convert this is multiply these two and add the numerator. Okay, so here and keep the denominator as it is. Here also 4 into 15, that is 15 4s are 60 plus 3, that is 63, and keep the 4 as it is. This is how you convert it. Okay. Now keeping the x, because I want the total kurtas, right? So keep x in the left side and take this 4 to the right side. It will become, when you take this 9 by 4 to the right side, it will become reverse, and therefore x is equal to 63 divided by 4 as it is, and it will go as 4 by 9 to the right side. Understood? Okay. Cancel 4 and 4 here, and 9 ones are and 9 sevens are. Okay. So therefore x is equal to 7. X is equal to 7. So how many kurtas he can make? is 7 kurtas he can make. Okay, so finally you can write it here. So therefore total number of kurtas is equal to x is equal to 7. It's a simple example. Hope you understood this. Okay, let us move to the next problem. Okay, now next problem is also finding three rational numbers between the two. These are also the two rational numbers, but represented in the form of decimals. Okay, so when decimal numbers are given, it's very easy to find out the rational numbers because we know that rational numbers are dense. Solution I have already written here. Since the rational numbers are dense, that is why I told you, listen to me carefully. Since the rational numbers are dense, any two rational numbers can be filled with many numbers. Between this, many numbers might exist. And how I am converting that? You see that, consider this 3.1415, I am considering it as 14150. Okay, so giving a 0 on the right side of the fraction is always allowed. So that I'll make it as 50. Okay, and I will convert the second number 3.1416 as 160, and I convert the last two digits as 60. You see that I converted. So this is just like making the denominator as same number, so that I can get a very long range between the two numbers in the numerator. So this is another way, that last two digits I am making it as 50 and 60, so that I can get the numbers between 50 and 60. Okay, I can get 10 more rational numbers between 50 and 60, 51, 52, 53, 56, like that. Okay, so that see what is the number after this. I can write 3.1415 is one number. If I add 1 here, this is a number that is there after 1415. Okay, if I add 2 also, 5, 2 also, that is the number, that is what I am doing here. So what is the number between 50 to 60, or 3.1415, 51, 51, 3414152, like this, 52, 53, etc. You can even write 3.14154, 155, 156, 157, any 9 numbers, totally 9 numbers you can have. Understood this, right? Okay, now suppose if you now listen to me. There is a very funny characteristic that exists. Since I am saying these are dense, these fractions are dense. Now can I find some numbers between these two numbers only? These two numbers only? Yes, I can still find. How? I will convert this. Listen to me carefully. 1415, 1 is there. Okay, I will write it as 2. That is the second number. Okay, sorry, it is 1510. I will make it as. So what is the next number? 11, 12, 13, and that is the number. All these numbers are actually lying between 14151 and 14152. These are the numbers that exist between these. Understood? That is the reason we call rational numbers are dense. Okay, you understood, right? Okay, let us quickly move to the next problem. Okay, now here they are asking, can you think of any other way to find out the rational numbers between any two rational numbers? So the two of the ways that what we have studied is uh, taking or making the denominator of the fractions to the equal number, so that I can have a range of numbers between the two numbers that appear in the numerators. That is one way. The other way is this way, that I just added 0 here, 0 here, so that I made it as 50 and 60, and added 51, 52, like this, 51, 52, 53. This is another way when they are given in the form of decimals. Okay, now I have another way that also I have already discussed, that you can add the two numbers and divide it by 2, taking the average. That is another solution that I am thinking of. Okay, if A and B are two rational numbers where A is less than B, then average of A and B, that is A plus B divided by 2, okay, is a rational number that lies between A and B always. Let me take the example that rational numbers that lie between one and half, sorry, half and 3 by 4. I can find out the value or a fraction that exactly lie between 1 by 2 and 3 by 4. How? This formula. This is the way that I am suggesting here. That take the average of the two numbers, and that average number will be always lying between the two rational numbers. Okay. How do I take the average here? It is 1 by 2 plus 3 by 4. Okay. Divided by 2. Okay, now adding 1 by 2 and 3 by 4 is as usual the law of addition given by Brahmagupta. So first convert the denominator of 1 by 2 to 4. Okay, so that is 1 into 2 divided by 2 into 2. 2 into 2. Okay, I'm keeping that as it is, and this is 3 by 4 divided by 2. Okay, let us do that as it is. So it is 2 by 4. Okay, 2 by 4 plus 3 by 4 divided by 2. It is equal to that. So it is 2 plus 3, that is 5 by 4 divided by 2. Okay, 5 by 4 is a fraction. Okay, now apply the law of division here. Law of division. What is law of division? Okay, you remember that? A by B as one fraction divided by C by D as another fraction. Then you can write this as A by B, and converting this division operation into multiplication, you can take the reciprocal of this. Reciprocal means denominator to the numerator and numerator to the denominator. So it will become D by C when you convert this division operation into multiplication. Can I do that here? Listen to me carefully. So 2 is always represented as 1 by 2. So this is actually like this. It is 5 by 4 divided by 2 by 1. It is like this. Okay, it is 5 by 4, it is 2 by 1. You getting my point? So when I convert this, it will become 5 by 4 multiplied by 1 by 2. 2 by 1 will become 1 by 2. Now with the law of product, I can multiply the numerators to the numerator and denominator to the denominator. That is the value that I'm going to get. You got my point? Okay, so I hope you understood this. Let me write this as 5 by 4 multiplied by 2 by 1 to 1 by 2. Understood, right? Okay, so finally it is 5 ones are 5 and 4 twos are 8. This is the answer. How did we went from here to that? So this is how you find out the difference, sorry, the average between the two fractions and that fraction. So therefore I can say 1 by 2 is less than 5 by 8 and it is less than 3 by 4. So by this representation, I am saying that 5 by 8, which is the average of these two fractions, lie between these two fractions. That is what they wanted. Understood? Okay, so what is the method that what we are suggesting, that taking the average of the fractions always gives you another fraction that lie between the two given fractions. Understood, right? Okay, so this completes the exercise set 3.4. Okay, so let us stop our discussion here only and continue with the concept of irrational numbers and representing those irrational numbers onto the number line in the next session. In this session, we have seen what is a rational number and how a rational number is represented on the number line, and how do you find out the rational numbers between the two given rational numbers. Okay, so let us meet in the next session to discuss on the irrational numbers. Okay, thank you.